Hey everyone, in today's investigation you had a chance to kind of discover the power rule for derivatives. So this is just going to be a short little video to kind of firm that up and make sure we've got everything we need to be able to use the power rule to find derivatives of functions. So the power rule looks like this. If my function is x to the n, so I have some exponent n, then my derivative, what we saw happen is we take our exponent and we multiply that out front, so n times x, and now we subtract 1 for our exponent, so that exponent becomes n minus 1. And that's the very basic idea behind the power rule. Now our constant function rule looks like this. So let's say f of x is equal to some constant c. Then our derivative is going to be equal to 0. So the derivative of a constant function is equal to 0. So let's look and see what this might look like in a problem. So we're going to use the rules we've learned to take derivatives of the following functions. And so obviously the nice thing now is we're kind of past that writing expressions using limits. We can just find a way to quickly find these derivatives. So for number 1, we have our function p equals t cubed plus 6t squared minus 5/3 t plus 16. So my derivative, I'm going to use the notation p prime. And now, since this is just terms being added or subtracted, to define the derivative, I just find the derivative of each term individually. So the first thing I'm going to start off here is with my t cubed. So my rule said to take that exponent and bring it down, multiply it, so I have 3. My variable stays the same, and now I subtract 1 for the exponent, so 3 minus 1 gives me 2. So that's my first term. My next term is a positive 6t squared, so I'm going to take that exponent and multiply it. Here I have a coefficient, so I'm just going to multiply those together. So 6 times 2 gives me 12. I have my variable t. Now 2 minus 1 just gives me 1, so I'm not going to write that in. Next, my next term, is minus 5/3 t. My exponent here is a 1, so 1 times a negative 5/3 is just minus 5/3. Now in this case, my exponent was a 1. If I were to subtract 1 from 1, I would get t to the 0. Anything to the 0 power we know is just 1. So actually now this just becomes my constant 5/3. And now my derivative of my last term, this is a constant term, its derivative is 0, so this is actually my final answer. I'm going to write it so it's a little more clear. So the derivative of the last term is 0, so my derivative is just 3t squared plus 12t minus 5/3. And that would be my answer. Notice in my notation I used p prime to denote the derivative there. So the second one is a very similar example, also quite simple and straightforward. Now, just for the purpose of demonstrating notation, I'm going to call this dy dx. And again, we're just going to use our power rule here. So my first one, my coefficient is really 1, so 4 times 1 is going to give me 4 times x, and my exponent becomes a 3. Minus, I have 2 times the negative 2 is minus 4x, and my exponent becomes just a 1. And my last term is a constant. Its derivative is 0, so that gives me the complete derivative of this function. Now the only thing that complicates this at all is when I have derivatives that have derivatives of functions with variable denominators, or they have rational exponents. So here's what we're going to do in that case. We're going to rewrite all the powers with negative or fraction exponents. And you'll see what I mean by that in a minute. Once we've rewritten it, we're just going to use our regular old power rule, and then we're going to rewrite the derivative to kind of match its original form. So let's see what that all really means. So if I look at number 1, my function is 4 over x to the 4th minus 3 over x cubed. So in this case, we're going to turn those exponents and we're going to rewrite them with negative exponents. Now notice, I'm not using derivative notation yet. This is still f of x. Instead of 4 over x to the 4th, I'm going to rewrite that as 4 times x to the negative 4th. And likewise for my second term, it's going to be minus 3 times x to the negative 3rd. Now I'm going to actually find my derivative, so I'm going to use my derivative notation, f prime of x, and I'm going to use the power rule. So I have negative 4 times 4 is a negative 16. My variable is x. Now here's where students tend to make mistakes. Remember, we're still subtracting 1, so a negative 4 minus 1 gives me an exponent of negative 5. I'm going to use the power rule again for my second term. I have a negative 3 times a negative 3, which gives me a positive 9 times x. And again, a negative 3 minus 1 is a negative 4. Now, that derivative is technically correct. However, since my original problem had positive exponents, I'm going to rewrite this to use positive exponents as well. So again, it's still the derivative, but now I'm going to rewrite this. My negative 16 is going to stay upstairs in my fraction, but to turn this positive, I need to move it downstairs. So negative 16 over x to the 5th plus, in this case, my 9 stays up, and my x to the 4th is going to go down, and that would be my derivative. Okay, now the same thing happens here. I see I have a square root of x. So I'm going to rewrite this first with a rational exponent. So instead of 3 times the square root of x, I know that's 3 times x to the 1/2. Again, I did not use my derivative notation yet because I'm just rewriting. This is still just f of x. So now I'm going to find that derivative using the power rule. I have 1/2 times 3 gives me 3/2 times x. Now here I have to remember what I'm trying to do is 1/2 minus 1. Well, if I think of that as 1/2, 1 is just minus 2 halves. So that gives me x to the negative 1/2. Again, this would be okay, but I can see this used the radical here, so I want to kind of rewrite this to do the same. So my first step would be, well, I have my 3 stays up top, my 2 is already down below, and this, to make it positive, I'm going to move it down to be x to the 1/2. I'm going to go one step further here, slide this up. Instead of using x to the 1/2, I'm going to rewrite this as 2 times the square root of x, and that would be my final answer. All right, so when you're back in class, then you'll get practice writing or using the power rule, but hopefully this should be a fairly straightforward process. All right, we'll see you back in class.